All right. Welcome everyone to our next session. We're going to get started here. We have Brian here to talk about generative AI forecasting for time series metrics. And Brian, I will turn it over to you. Oh, Brian, you're on mute still.
That was going to be my first question. All right, so
I'll go now.
generative. Okay, awesome. Generative AI for time series metrics is the topic, and we're talking about forecasting, prediction, and anomaly detection. I'm the principal product manager for the Cisco time series model in our Essential AI team, and that's what we'll be talking about today. All right. So we all understand the traditional ops playbook, right? Set a ton of static threshold alerts to detect when a KPI has crossed a threshold, right? Then we focus a lot of our attention on responding fast and fixing fast, right? We've gotten quite good at it. Many sessions in this series will talk about that specifically. But so often this means that we start working on a problem after it has already impacted our customers, right? What we need is a shift. We need a shift from the traditional detect and respond to what I like to call predict and prevent, right? We want a system that automatically senses that there are changes in our service, right? One that can predict the future, right? And tell us how long we have to fix a problem. Tell us in advance so that we have time to prevent that problem from affecting our customers. That doesn't mean 10 seconds in advance. That means hours, so at least several minutes, maybe hours in advance, depending on what's causing the particular system, right? The name of the game is now keeping our availability SLA in the green, right? Something that we are all tracked against, whether or not we are in the green or in the red with that all critical metric, right? We no longer accept when a service is down. I don't, you don't, our companies don't, right? We need to shift our focus from the traditional metrics of mean time to respond or mean time to restore a service to thinking about mean time to prevent, right? How far in advance of an incident can we detect the problem? Can we give ourselves enough time to actually solve that problem before it becomes an incident, right? Before it impacts our customer's experience. That's the new name of the game. And we're going to do this with a variety of tools. We're going to do this with anomaly detection, and we're going to do this with predictive alerting, forecasting, right? But these are not new concepts or new capabilities, right? They've been around for some time now. We've been chasing this goal for decades, probably as long as many of us have been in the technology space. However, reliable and ubiquitous anomaly detection and forecasting across all of our KPIs and all of our workloads still remains elusive, right? It typically involves a data scientist training, tuning, retraining models for specific use cases, right? So you may have it in one particular area of your site on one particular really critical service, but you don't have it across all of your workload, right? It's just not scalable, reliable, or cost-effective enough at this point in time with the existing technologies. And the way that our services are growing, right? The complexity of the services, and I would even say are very popular now AI coding practices and this trend that will be taking off really makes these challenges more difficult, right? The challenge of applying static thresholds across our entire real estate is just not realistic. It's not feasible anymore, right? Now that's what takes us to today, or the start of this new phase, this new era, right? A new wave of generative AI capabilities for time series metrics called time series foundation models, aka TSFMs, because we love acronyms, is positioned to change the observability game. All right. It's going to be powering the shift to predict and prevent. Now, I want to be honest here in advance, right? This slide makes it look like it's going to be the panacea for all of our ills and solve all of our problems. We are at the beginning of this technological shift, this sort of revolution in how we observe our systems, right? So let's get into it. We're very excited to announce our time series foundation model, the Cisco Deep Time Series model, which is now available in public beta in Splunk. And by public beta, I mean that anybody can go and use it right now. We keep it in beta as it's still evolving. We're rolling it out very fast. We're iterating on these changes. So we still keep it under the beta mode, but it's available full capabilities for you to go use it right now. And since this is a Developer Day, Hacker Day event, it's also available to the open source community. That means these capabilities that we'll be talking about today are not only available for your workflows that are inside Splunk, but they're also available for workloads that are outside of Splunk, right? Whether you have some automation or you have an agentic workflow and another workflow management or agentic orchestration platform, you can get the same type of prediction, at least, and forecasting capabilities in both environments. Right? So think about a time series foundation model as an LLM, right? Large language model, but for numbers instead of words, right? Specifically time series numbers. In the same way that a large language model sees the relationships between words and understands them to the point where it can start to reason about language, right? A time series foundation model is doing the same thing for these relationships between numbers or small patches of numbers and seeing how they relate to each other, right? Both temporally and oftentimes across other time series that might be related to it, right? This gives us the primary capability of a time series foundation model, which is forecasting, right? Look at the past, a lot of the past, in order to predict a shorter amount of the future, right? Now, we can use this forecast for a few things that are critical for us. One of those is predictive alerting, right? Tell me if my KPI will violate an SLO in the next period of time. Hopefully more than a couple of minutes, up to a few hours, right? We're still in the operational time zone time frame because we want to be accurate and precise, right? And really what comes down to it is the golden thing that we're all looking for is anomaly detection that can easily be applied to any metric on any service without having to involve your data scientist, right? Without having to spend a lot of time and investment on solving one problem, but we can apply it everywhere, right? Again, coming back to this trend in AI coding, where we're not going to be as in touch with the KPIs and the performance of our apps anymore. So we need other AIs to watch those AIs, right? Now, time series foundation models are not a brand new thing. They're pretty new, but not brand new. Ours is not the first in the market, but we are in the leading edge of the game. Others, large labs like Google, AWS, have been creating time series foundation models for about 1.5 years, maybe 2 years, right? Ours is unique in the sense that we are focusing on machine data. Cisco Deep Time Series foundation model, Cisco Deep Time Series model is a machine data specialist. It's been trained on over 2 trillion machine data use case data points. And we are dedicated to making this time series model the most accurate and reliable time series foundation model for machine data. Another thing that makes this model specific for machine data is its support for seasonality. Here I say the season is the reason, right? our services that we deploy out to either end consumers or internal enterprise organizations typically have some level of seasonality to it, right? Either a daily seasonality, every hour maybe have a little different patterns to it, different days across the week, maybe different weeks in the month have different trends or expectations. And we don't want these alerts that we have set up to be going off for known expected patterns, right? Ideally, even we get to the point where there are known patterns that aren't cyclical that we can identify in advance to know that our alerts aren't going to trigger for them, right? Our time series foundation model, the Cisco time series model, is unique in the space in the sense that we can see up to 32,000 data points of the signal's history, right? Other time series models are around 4,000 to 8,000. Google's is around 16,000 data points. Now, what that means is that we can see 3 weeks, maybe in 3 months of a signal's history to see the patterns, right? To see the patterns that exist in the past. However, one of the trade-offs that typically exist with the other time series foundation models is either with that smaller amount of window, that smaller memory, say 4,000 minutes, 8,000 minutes, right? That gets you into a couple days, maybe not quite even a week of the history. You can't see the seasonality patterns with that. These other models can't really support this critical need that's necessary for machine data with that limited amount of view. So the trade-off is they'll say, okay, we'll use larger aggregation points instead of watching at 1 minute aggregations or 5 minute aggregations. They'll say, use 10, 15 minutes or an hour. Well, then you can see some trends in a data cycle, but you can't see the near-term precision, what's happening recently, right? The trends, the changes in the systems that has created a pattern that now is going to lead to an incident. So if you're going to change the way we do observability for machine data, we need to see both domains, right? We need to see the forest and the trees in this situation, right? We need to see the recent detail and the long-term range, and that's a unique architecture that we've brought to the market in the Cisco time series model. We call it multi-resolution encoding or multi-resolution architecture. And we're quite excited about it, and it's really showing specific improvement. We've seen about a 20% accuracy improvement between our model on machine data and the leading competitor models for the machine data. The other thing that makes our model specifically attuned for machine data is the breadth of the data domains that we are already trained on and that we are continuing to train on as we expand the model throughout the roadmap this year. I'll be honest that not all these domains are covered in the model we have now, but as being owned by Cisco and part of the Cisco ecosystem, right, we have access to a broad range of machine data domain types that other vendors are they're just not positioned to do. Those who are in this space typically are not broadly positioned to access all this data, or if they are, like some of the hyperscalers, like clearly Google can do whatever Google wants to do, they're just not focused on this space. This is something that we are focused on and committed to bringing all these data points to bear. The way that a time series foundation model has its sort of secret sauce is that because it's been pre-trained on all of these different shapes and patterns in machine data, that it can show up to any use case or any scenario, see the patterns in the past, understand them because it's seen them before, right? In the trillions of data points that it's seen these patterns and these relationships. So it doesn't have to be pre-trained, right? You don't have to spend any time saying, I'm going to train a model on this particular use case that can only solve these particular problems. I like to say, you show up, you throw the data at it, sub-second response time, it gives you the forecast. These are operational forecasts. The initial sort of batch forecast it presents will be in the 2-hour to 10-hour range. You can have it auto regress itself and go out longer in the ranges. Of course, with any prediction, the further you get out from now into the future, the less sort of certain you are. But we have remained pretty strong in our accuracy for operational type timeframes. All right. So before I jump into how can I use it, I would sort of ask our moderator if there are any questions that I've queued up that I should address.
Yeah, we have a few, and I think you've sort of covered some of them, but I'll still run through them quickly. So the first was just around historical root cause monitoring with AI.
Okay.
There wasn't any elaboration. That was just,
Okay.
Is that included
That
at
was
all?
the question.
Yeah.
Historical root cause analysis with AI. So I do talk a lot about alerting because that's sort of the leading part of the process. I should also say that this capability does apply to basically to all stages of the high level life cycle or process trends, right? Everywhere from if you don't want to have problems, especially as it relates to capacity, forecasting your capacity in advance, right? What have you used in the past? Where do you think you're going to go in the future? Then, of course, alerting. But then once you get into incident response, root cause analysis, this is where it plays an important part too. Typically, your root cause analysis agent, ideally some sort of agentic process, will determine the scope of your potential problem set, right? You have some symptom, you trace back and you find all of the entities that might be involved, all of the metrics that might be involved. From those metrics, you may have thousands, 10,000s of metrics that you need to sift through to find out if there are any leading indicators that may have caused this particular symptom, right? And so the first thing you want to do is say, okay, AI platform, plow through these 10,000 metric time series instantly and return me back the small subset that have anomalous behavior in them, right? And this is important because oftentimes in this process, you want to be more greedy, right? You want more things to come into your funnel, right? Because just because something didn't trigger an alarm that needed to be actioned, doesn't mean that system behavior change didn't affect, upstream, didn't affect your particular service downstream. It could have been a key part of the root cause analysis equation. So really, this is a capability that supports all of those trends. I did shift this talk more to prevention, but also it has a key role in MTTR and response and getting you back online faster by accelerating your root cause discovery. Hopefully that answered the question as vague as it was.
Great. Thanks, Brian. Okay. We got a couple more. I'm more interested in MTTF, mean time to forecast. How long does it take for a customer to get there?
I'll be hyperbolic and say 0, right? And so the mean time to forecast, like for example, in Splunk, this is already available. We'll talk about where it's available. So any time series query you make, right? This is time series data. It can come from log data. It can come from metric time series rows data. But you're going to do a time chart function or whatever to cast it per every minute. Once you have your time series forecast, I'll show you how easy it is to apply here in a second. You just say apply this model, and that time series forecast is sent to the time series model, and it immediately gives you a forecast, right? Now we've set some. You can control how far you want the forecast to go out. You can change your confidence bands. We'll show those things. You can tell it to do anomaly detection. It'll do those too with some defaults. So there are some sensitivity settings you can have in anomaly detection, but there's no tuning you have to do. So the time to forecast really 0 for all sort of intents and purposes, without sounding too BS there.
All right, sounds good. Okay, then there was a question about whether this was published on a Hugging Face. Someone shared a link, but there was some confusion over whether that's the most updated version on there. Do you happen to know?
Yes. So, like I said, this is available to OpenWay community. We have been doing all of our work in the open. We are now at an Hugging Face version 1.0 of our model, which was released in February, if I recall. We did release a preview model in November, but so make sure if you're using it, you update it to the latest 1.0 version of the model. And that has been trained on our 2 trillion data points. Still mostly observability domain as we're working on the training for all the other domains.
Okay, great. Then we have two more, and then I'll let you get back, because I want to make sure we have time to finish the
Yep.
presentation, and we can see if we have time at the end. This one I think you mostly covered, but how does it handle abnormal seasonality? Anything to add, or do you think we're good there?
Well, you have you have abnormal and seasonality.
Okay.
So I would say it handles complex overlapping seasonality well, and because that's one of the primary things we're focused on. We are always working to improve seasonality, which is another great thing about this model, especially when you use it inside the Splunk platform and our Cisco Deep Time Series model. Which right now, Cisco Time Series model is the name we use for the open weight community. Cisco Deep Time Series model we use for the intra-product experience, and that's on a hosted platform. So we will update that model sooner than we update the open weight model, just as far as ease of publishing internally. So that model, where's it going? Was that the open weight community question? Sorry, I was getting into my flow there. Lifeline there, host. What was the question again? Sorry.
It was around abnormal seasonality.
Oh, sorry, abnormal seasonality. Yeah, so we're always improving our seasonality focus and response. So it does support overlapping seasonality really well. Abnormal seasonality, I'm not sure what that means necessarily, but that's one of the primary focuses of the model.
He actually gave a little context. We said shifting weeks. Like this person works in higher ed, so shifting week.
Okay, so any prediction is based on a pattern. I see the pattern in the past. I predict the model in the future. Our next iteration of the model is no surprise, because this is where the market is. But we're working on multivariate and covariate capabilities. So that's the great thing about being on this path, is that it is evolving. We're at the beginning stages of this, in the same way that LLMs have evolved dramatically over the last year and a half, right? Unbelievably. So the next release will be supporting a thing called covariates, which you can inform the time series prediction of additional patterns. So for example, if you have a holiday coming up and you're hired ed and spring breaks coming up, right? Well, you know what happens when you have a dip in attendance. So you can pattern out that dip in attendance or dip in class schedules in another time series, and you can pass that into the prediction model and say, oh, I'm predicting system usage, but also here is the pattern of attendance schedules, and next week it's going to be no classes. It's going to be down. So expect system behavior to be low, and the prediction will accommodate that additional future forecast knowledge to support that, if you will, abnormal seasonality, or I like to think of it as non-cyclical seasonality. And you're right, that is really a thing we've been chasing for a long time in the anomaly detection space. Is there are things that I know as a business that aren't represented in the near term or even the past few months pattern, but I want that to be accommodated, so I'm not, alerted for things that I already know, right? Or it could be planned outages or maintenance windows and those types of things. So yes, actually, good question.
Great. And we have two more questions, but I want to make sure you have time to finish your presentation. So we'll hold those two.
And I can come back to it here, right? So how can I use it? This is a Splunk Developer Day conversation, so let's talk about it in Splunk. Again, if you are a Splunk Cloud user, we make it super easy. The whole point of this feature is to make forecasting, anomaly detection dead simple. We're looking to expand the usage pattern beyond your AI toolkit, ML toolkit, sort of aficionados who are doing data science work, to every engineer, DevOps, ops, security analyst, etc., who is operating these platforms, need to be using these tools. We need to, hate to say that, democratize this feature for everybody, right? So we made this available as a Splunk hosted model, right? As long as you are on, you have installed the latest version of AI Toolkit. AI Toolkit is the delivery mechanism, so we can get this out to the door to you in a fast and iterative manner. Then if you have the latest version of AI Toolkit, 5.7.3 at this moment, all you have to do is get your time series. In this point, in this demonstration here, I just cheated and used a lookup file. And then to say apply CDTSM, which is the acronym for the model, and the field, or I should say the metric name that you are looking to forecast. That simple. Now, this view doesn't show any of the parameters. There are additional parameters that you can choose to use to control things like the forecast length or a holdback period or the confidence intervals or the quantiles that you want to see. But those are all have defaults, so you can keep it simple and only modify it when you want to get a little bit deeper. Anomaly detection, known as a realm of complexity. To start with it, all you have to do is take that same forecast you did and say mode equals anomaly. There's mode equals forecasting, mode equals anomaly. Enter, boom. You have yourself a anomaly detection graph that I'll show you here in a minute. And we try to think about there's one sensitivity knob that you can tune up or down. There are some other controls, but we like to keep those all simple and default from the start. If you are a on-premises Splunk customer, you can also take advantage of this. We want to make sure this is available to all of our Splunk users. So we'll talk about how you can download the model, install it on one of your servers, any server, right? It doesn't have to be a Splunk server. And then you can just point your AITK conf file over to it, right? I'm being mindful of time, so I'm going to move a little bit faster, but try not to talk too fast. So here's what it looks like, right? These are new visualizations I'm excited about, where you can see a signal history and the forecast period. The bands around that are your confidence interval, right? That's made by an upper quantile band and a lower quantile band. By default, this is the upper 90% and the lower 10% quartile. The math works out. We call that the 80% confidence interval. Those are all changeable, but that's a good place to start with. And this doesn't show a default time period. Actually, no, it does. Of 128 data points. So that could be 2 hours at 1 minute, or that could be 10 hours at 5 minutes. That's the default patch, and you can extend that patch. You can specify up to 15 quantiles if you want, but usually you don't. Mode equals anomaly. You get a visualization like this, right? This is a brand new visualization for anomaly detection. Again, really enriching the anomaly detection capabilities of the platform. And so here you can specify up to a 24-hour period where you want to identify anomalies. This is that case where we look back for an RCA type of situation. Say there was an incident around, I don't know, 10 o'clock or so, that we want to look in the past before that. So we set this 8-hour time period here and said, look for anomalies in that period. And you can see we set a detection earliest and latest window to define that window. You can also say relative, look in the last 4 hours, 5 hours, whatever it may be, for anomalies. And then you see a couple things here. You see the dotted line here is again, the forecast. The little blue bar around it is kind of small here, but that is the confidence interval. And then we have a default sensitivity multiplier. Here it's set to 5. That gives you more room around the confidence interval. If you just said, is this statistically an anomaly or not? You'll get a lot of quote unquote false positives, because while they are statistically an anomaly, you probably don't care about it at that level, right? So you can control the sensitivity that is relevant to your particular use case, right? It's hard to find a one-size-fits-all situation that magically knows what you're trying to do for that particular use case, whether it be root cause analysis or whether it be accuracy. Not accuracy, but alerting in the realm or the level that you care about it to be actionable. So we do give you a default start point and a simple knob to turn. And if you want to go deeper, we'll give you more knobs to turn. That's the Splunk way. We don't want to limit you, right? But we're talking.
Hey, Brian, so sorry. I'm going to have to give you like a 1 minute warning. We're butting up on the next session.
Well, that's perfect.
Okay.
So I'm going to take 1 minute and 30 seconds. So these next two slides, I don't expect you to read them here, but you can screenshot them or take them offline. These are also available in the docs and on GitHub. It's not as pretty. So you can go to Hugging Face. This is developers coming the hacker days. So you should install it on your local laptop, play around with it, etc. Runs great on your MacBook Pros. Go to Hugging Face, clone it, start the Docker container. You're up and running. You have the model running. HTTP call to the endpoint to check if it's up and running. You're good to go, right? If you're vibe coding, I've created some awesome little forecasting and anomaly detection tools real fast using vibe coding, right? If you're installing this on premises, It's basically the same thing, but there are a couple more instruction sets to get your bearer token that you want, and then to register the changes in AIDK in order to point over to that model. And with that, I'm coming in almost exactly at time. There are some links. You can go to the docs. You can go to GitHub, has lots of content, examples, Jupyter notebooks to play around with. Hugging Face, of course, is where the repo is. And don't forget that you can use the Splunk MCP server to make calls and to invoke this forecasting and anomaly detection from outside the product as well. And finally, I would say thank you for your time. Mr. Moderator.
Awesome. Perfect timing, Brian. Thank you. We did have 2 questions. I'm going to copy those into the chat in the lobby, Brian, if it's possible for you to get in there and answer them. Got a lot of great feedback. For everyone else, we have our next session starting momentarily. Please hit the agenda button, go over there, and I'm actually going to end the session. So you can just head back to the lobby and join the next one. Thank you again, Brian.
Cheers.